Good morning, and welcome to the virtual technical seminar on the important changes within AMS 2750F. My name is Andrew Bassett, President and owner of Aerospace Testing and Pyrometry. Today we'll take a look at the major key changes of AMS 2750. AMS 2750F is a result from a 5-year review and an update of the specification. AMS specifications are typically looked at every 5 years to be revised and updated when required. AMS 2750 is a specification that covers all pyrometry requirements for equipment used for thermal processing of metallic materials. This document goes across various industries, obviously with aerospace heat treating. It also goes across medical device manufacturers, those who are heat treating hip implants and dental drills. The FNA has adopted AMS 2750. The pyrometry spec is also seen in the chem processing or plating houses for those who have curing ovens or drying ovens now have to follow the requirements of AMS 2750. So today we're going to look at a 30,000 foot overview of some of the major key changes in AMS 2750. AMS 2750F subteam formed in October of 2017. We developed a team that was across the broad industry of aerospace, including service providers, NADCAP heat treat auditors, and staff engineers, thermocouple suppliers, several aerospace primes, and including some raw material suppliers. We had myself, Andrew Bassett, with Aerospace Testing Pyrometry, Marcel Cooperman from PRI, who's also a staff engineer for NADCAP Heat Treat Task Group. We also had James LaFollette from GeoCorp, Doug Matson from Boeing, Brian Reynolds from Arconic, Doug Schuler from Pyro Consulting, as well as a NADCAP Heat Treat Auditor, and Cyril Bernal from Safran Aerospace. He's also the Task Group Chairman for Heat Treat Task Group. So with the group that we had, again, this broad array of people from different parts of the industry. Looking at Cyril from the European standpoint, we had Brian Reynolds from Arconic, who is big with the raw material producers, and again, some of the aerospace primes. So this gave us a good, well-rounded team to go through AMS 2750 and start the revision process. When we decided to go to the next revision of AMS 2750, we wanted to make sure that we clarified any incorrect or misinterpreted items that were in the previous specification. We used the PRI Pyrometry Reference Guide. We also used the NADCAP audit advisories that dealt with pyrometry. And obviously we needed to update to the latest technologies and data acquisitions. These AMS specifications are looked at every 5 years, and this was the 5th year for AMS 2750, so it was time for a revision. So if you notice that AMS 2750F has expanded from 43 pages to 54 pages. We had expanded the definitions from 79 to 87. Tables expanded from 11 to 25. People have complained a bit about where the tables are located, but in accordance with SAE, tables are now placed when the first reference within the body of the text. A lot of the tables were added and figures were used to clarify any of the requirements. Now moving on to some of the changes when it came to temperature sensors. We did add additional sensor types, type M, which is not official designation by any international standards organization. It's a nickel-nickel moly thermocouple. We also added type C, which is a tungsten rhenium, also known as a refractory thermocouple. Another sensor that was added as well was RTDs, a resistant temperature device, though we only limited those to platinum type class A. One of the key changes when it comes to the accuracy of thermocouples is all thermocouples, base metal thermocouples, shall meet special limits of error, which is plus or minus 2 degrees Fahrenheit, or 1.1 degrees Celsius, or 0.4% of reading, whichever is greater. In AMS 2750E, that was only a requirement for SAT sensors or control and recording sensors that were used in class 1 or 2 furnaces. In Rev E, we also allowed standard limits of error for load thermocouples and TUS sensors. In this change in Rev F, All base metal thermocouples, no matter what their intended use is, shall be special limits of error. When it comes to type B, it's plus or minus 1 or 0.6 degrees Celsius or 0.25% of reading, whichever is greater. And for types R and S, it's plus or minus 1, 0.6 degrees Celsius or plus or minus 0.1% of reading, whichever is greater. But if you do have a type B, S, or R sensor that does not meet these required accuracies, then those correction factors shall be applied during all thermal processing. One of the major changes that occurred in AMS 2750 when it came to thermocouples was those that are being used for test sensors or load sensors and their expendable type thermocouples. The changes that we made on there were based on studies that the AMS 2750F subteam conducted during the draft portion of the specification, where we saw some considerable drift when it came to expendable base metal thermocouples. So we made some restrictions in regards to expendable base metal thermocouples, and they are as follows. So all expendable base metal sensors that are used below 500 degrees Fahrenheit, 260 degrees Celsius, you're allowed to use them for 3 months for unlimited use. For expendable base metal thermocouples that are type M, T, K, and E, and they're used between 500 and 1200 degrees Fahrenheit, you're allowed to use them for 3 months or 5 usages, whichever occurs first. We did give some extra usages for types N and J thermocouple when used between 500 and 1200 degrees. They can be used for 3 months or 10 usage. Any expendable base metal thermocouple used above 1200 degree is now limited to a single use. There are a few new changes when it comes to the documentation for temperature sensors for results and records. Obviously, we'll need the date of calibration or recalibration. We need to know the quantity of sensors, or if you're purchasing a spool in rolls or lengths of wire, we need to know the length of the wire. Identification if this is an initial calibration or a recalibration of the sensors. We need to know what the required calibration accuracy, which again is going to be the special limits of error, plus or minus 2 or 0.4% of reading. And then the user's quality organization shall approve these certifications. In this next section of AMS 2750F, we're going to go through the key changes on test instrumentation, process instrumentations. We address now offsets in a more clear and concise manner. And we'll also talk about the documentations of the offsets and your calibration records, dealing with records and results. Some of the new general requirements when it comes to test instrumentations per AMS 2750F is one thing we addressed was addressing the calibration period for all test instruments. Will begin on the date of calibration. There were some misunderstandings. For instance, if you had 2 test instruments that were calibrated on the same day, but one sits on the shelf in a laboratory and one's being used out in the field, and let's say a couple months later you bring the one that's in the shelf and bringing it out in the field, that's actually when your calibration interval would start. And no, we said your calibration date is when starts when the date of its first calibration. We also addressed that you're now allowed to use primary and secondary standard instruments can be used in the field to calibrate your process instruments. We do have a couple caveats on that, is that they must stay within your environmental limits as described by your manufacturer's tolerances. So if your manufacturer's tolerance for a standard instrument says as long as it stays within 105 degrees Fahrenheit and less than 90% humidity, and your shop is in that realm, yes, you can go out and use your standards to calibrate your process instruments. The one thing we do hold back on is that the calibration frequencies for those test instruments, if they are brought out into the shop floor, the frequency would be reduced to a quarterly interval. For instance, a primary standard, if it stays within the laboratory, the calibration interval is 3 years. A secondary standard's once a year. But once those are removed from the laboratory environment and brought into the field, the calibration frequency drops to quarterly. Lastly, field test instruments. These would be your instruments that are used to do system accuracy testing or calibration of the instrumentation on the furnaces, or your temperature uniformity survey recorder data acquisition. they now have to have a minimum readability of 0.1 degree Fahrenheit or 0.1 degrees Celsius. Some of the test instruments out there that are being utilized now, once the readings get above 1,000 degrees, they lose their decimal point. So that's one change that people should be aware of when it comes to your test instrumentation. Some of the key changes when it comes to the process instrumentation for AMS 2750F, and the process instrumentations are your control, your recorders, our data acquisition system, over temperature instrumentation, are as follows. Over temperature instrumentations are going to require calibration. In AMS 2750E, they actually did not require calibration if they were being solely used for over temperature protection of product or the furnace. The big change is going to come when it comes to your data acquisition. The new requirement is that the readability will be 0.1 Fahrenheit or 0.1 Celsius, depending on where you're processing, 2 years after the release of AMS 2750. So June of 2022, there's going to be a requirement that your data acquisition will have to have 0.1 readability Fahrenheit or Celsius. This is actually fixing a flaw within the specification. It's twofold. For those who are processing in Celsius and you had a requirement of your instrumentation to be plus or minus 1.1, and your data acquisition system did not have 0.1 readability, then how would you show compliance? Likewise, in AMS 2750, the accuracy requirements for those instruments is plus or minus 2, or as I mentioned before, 1.1 Celsius, or 0.2% of reading, whichever is greater. Again, if the instrumentation does not have a readability requirement of 0.1, then how would you show compliance? And originally, in the first several drafts of AMS 2750F, this was required on all digital instruments. But we compromised and made it for only data acquisition systems, since that is the permanent record. Likewise, with multi-channel data acquisition systems or recorders, channels that are not calibrated now must be tagged or blocked for unintended use. So somehow you're going to have to block those channels that aren't being used. For instance, you have a vacuum furnace and you're using 3 channels for your load TCs and the other 9 channels are not being used. Those channels in the back of the recorder will need to be blocked off, or some sort of documentation or tag that shows that they are not being used. One good thing is that sensitivity checks for digital instrumentation is no longer required. The sensitivity checks are only going to be required for analog equipment. And we also put a new table in, Table 10, which defines what is an analog instrument and what is a digital recorders. So we have the paper versus paperless recorders spelled out in Table 10 of AMS 2750F. We now have some new requirements when it comes to timers and the calibration thereof. There is going to be required an annual calibration of timing functions for all digital recording instruments to be plus or minus 1 minute per hour. For those that have a documented digital synchronization of timing systems to NIST or international standards via satellite or internet or some sort of telephonic systems periodically, at least on a monthly basis, we're saying, to support the plus or minus 1 minute per hour, this accuracy is acceptable. So if you have a documented procedure that states we have a system in place such as the digital synchronization of timing systems to NIST, this would be acceptable. Furthermore, they are requiring on a biannual calibration, so every 2 years, of any external timing devices for all digital recording systems to be plus or minus 1 second per minute. So if you have a timer or a clock or something that's on your furnace for your times at temperature, these items will need to be calibrated once every 2 years. There's now some new added documentation requirements when it comes to the calibration of process instrumentation. First off, you have to have a unique identification of the test instrument used. So if you have a asset ID number associated with a test instrument used to calibrate the equipment, that's just going to have to be denoted on your calibration documentation. You also have to identify each sensor that may be calibrated or signal that would be calibrated. For instance, you have a vacuum furnace that has a type S control and over temp thermocouple, and there's K load thermocouples inside the furnace. You're going to have to denote that the control sensor and over temperature are type S, as well as the load thermocouples is type K. The location of where the calibration is taking place will need to be noted as well, but only if you are invoking the alternate SAT. This is a requirement in the alternate SAT process where the calibration must be performed from the point of connection. Other aerospace primes do require connections, the calibrations be performed at the connections. So if you're doing it for another aerospace prime, such as GE, to their specification, they require from point of connection, you would have to denote that on your calibration report. You have to list out your nominal calibration temperatures. And some aerospace primes may require by material spec or process specification that the error of a field test instrument and the instrument under calibration must be incorporated into the calibration. And lastly, the approval of an authorized agent for the calibration agency if performed by a third party. So if you have a third party company calibrating your equipment, their quality designee or the quality manager will now have to be required to sign off on those certifications as well. One of the places that we believe that we made some great strides in AMS 2750F is putting some more meat and potatoes behind the use of offsets. Again, one of those items in the specification that has caused a lot of problems of how to document what type of offset is allowable or not. So the group decided that we'd make two different offsets. We call them a modification offset versus a correction offset. So a modification offset is a manual or electronic adjustment of an instrument to compensate for known conditions such as, but not limited to, a skewed uniformity survey distribution or the control sensor placement in a muffle or retort type of furnace. So in other words, you're taking the nominal temperature and shifting it away from nominal. Whereas a correction offset, again, is a manual or electronic adjustment of an instrument to compensate for known errors in a measurement system. To make the system more accurate. So the correction offset is bringing the instrument back to a nominal. For instance, you're doing a calibration of a process controller and it reads 2 degrees off and you want it to be accurate. You would go in and possibly use the offset or bias or input shift, different trade names for different instrument manufacturers, and use that electronic offset to bring it back to the nominal temperature. We also mentioned that SAT modification offsets are not allowed. So in other words, if you have a failed SAT sensor, you won't be able to use a modification offset to compensate for the failing thermocouple. You will have to replace the thermocouple and retest. There now is a new instrumentation type in AMS 2750F. We now have instrument type D+. Prior to this, we had instrumentations A through E in Rev E, and now we have D+. So D+ instrumentation is an additional recording sensor that is located at least 3 inches away from the controlling sensor position, and it also has to be of a different type sensor. For instance, if you had a type K controlling sensor and you want to go to the type D+ instrumentation type, that second recording sensor would have to be a different type. So you could use type J or type N or type S. And again, it has to be 3 inches away from the controlling sensor, and that sensor would have to be recorded. It was nice to have Saffron on the AMS 2750 sub-team. They had pointed out to the rest of the committee that this is a typical instrumentation type in the European theater. So it was nice to understand that that the Europeans may be doing something a little bit different, and like that addressed in the AMS 2750F. We addressed the additional sensors that are permitted during thermal processing for furnaces with multiple controlling zones that are 225 cubic feet or less. So this actually deals with type A and C instrumentation. So when you're locating a hot and cold temperature recording sensors, again for type A or C, the furnace shall be treated as a single zone control zone furnace. Also, when you're determining the number of load thermocouples that need to be used, also for types A and B, required regardless of the number of control sensors. So anything that's 225 cubic feet or less that have multiple control zones can be treated as one single control zone. For those that are larger than the 225 cubic feet, as long as the greatest dimension of width, length, and diameter or height is no more than 3 times any other dimension. If it is, then other sensors will be required. So now we're on to some of the key changes in system accuracy testing. So one of the items that we addressed that was previously a NADCAP heat treat audit advisory dealt with these advanced control systems that are control and the recording system is integrated from the same measurement circuit. It cannot be different, only now they're only required to document a single display or recorded reading for an SAT. Again, these would be for those advanced systems such as a PLC control or Honeywell HC900 or a Yokogawa control data acquisition system as one, since it's the same circuit just displayed two different ways as a control and recording sensor. When you do conduct an SAT, only one value is required to be recorded. We also addressed for furnaces with multiple qualified operating temperature ranges. A comparison SAT, if that's the method that's being chosen, shall be performed within each range at least annually. For example, if you have a class 2 plus or minus 10 range from 800 to 1500, and then class 3 from 1500 to 1800, and class 5 from 1800 to 2200, an SAT at least once a year will need to be conducted in one of those each ranges. So the plus or minus 10, the plus or minus 15, and plus or minus 25. Doesn't necessarily have to be conducted all at the same time, but at least on an annual basis, all three of those ranges are covered. We also spelled out some more requirements and clear definitions, clear understanding of what a comparison SAT is versus an alternate SAT and the SAT waiver. I think the team did a good job of clarifying these requirements a little bit further. In regards to the resident SAT sensor and testing, the position shall be verified during the SAT sensor installation and replacement when affixed in a position to an assembly to prevent movement. So in other words, you have to verify your resident SAT during your system accuracy testing to make sure that it hasn't moved. The resident SAT sensor may be located independently of the sensor under test, and its position shall be verified before each test. Again, you can have the resident sensor permanently placed in there and make sure that it doesn't to move and verify it each time, or you can remove the resident SAT sensor but put it back in the same location as long as it's documented that it's verified in the same location. When it comes to the alternate SAT process, in the previous revision in Rev E, there was a lot of misunderstandings, interpretation when it came to the alternate SAT process. So in Rev F, we made some good strides on defining what the intentions were when it comes to the alternate SAT process. First off, it applies to load sensors that are used once or for other control or recording sensors replaced at the same or less frequently than the SAT normal interval. The calibration will need to be performed from the point at which the sensor will be connected, and if one of the following three options are met. Option 1, the sum of the sensor calibration error plus the instrument calibration error, or you can use the sensor calibration correction factor plus the instrument calibration correction, shall meet the maximum SAT difference. In other words, you're taking the calibration report from your process instrumentation and the calibration reports from the load thermocouples, combining them together, and as long as they're within the allowable SAT tolerance, that meets the option 1 of the alternate SAT. Option 2, use the appropriate sensor and instrument calibration correction factors when applied manually or via programming as allowed by the calibration limits of AMS 2750. So when the data used from the control and recording instruments combined meet the maximum SAT difference. And option 3, limit your instrument calibration error correction factors and or the sensor error or correction factors so that the sum of the errors or correction factors cannot exceed the maximum SAT difference. For example, you restrict your calibration of your process instruments to no more than plus or minus 1 degree, and your thermocouple correction factors no more than 2 degrees. In the worst case scenario, your tightest tolerance for an SAT for a class 2 furnace is plus or minus 3 degrees. So if you restrict your calibrations to 1 and your thermocouple correction factors to 2, add those together, they're within 3. So that is the third option when it comes to the alternate SAT process. When it comes to the documentation of the alternate SAT process, AMS 2750 left a huge void and didn't tell the suppliers how to document this process. So in RevF, we put some requirements in the documentation for the alternate SAT. First of all, you're going to have to identify the thermal processing equipment. What furnace is this alternate process going to? You have to identify the sensor system that's being tested. If you're replacing your load thermocouples every run, so you'd notify that it was the load thermocouple. You would have to identify the sensor or wire or roll of wire that the SAT process. You want to list the date and time the alternate SAT was performed. Identification of the reason why the alternate SAT was performed. So if you're just saying we have a single-use thermocouple, replace it, you could put in your documentation single-use sensor. Final alternate SAT results when you're doing calculated for the method used. Identification of a technician performing the SAT, the alternate SAT, identification of the agency if the alternate SAT is done by the third party, and approval both by third-party authorized agent and quality organization. So finally, we have some documentation requirements when it comes to the alternate SAT process. There have been some slight changes to the SAT waiver option. Noble metal load thermocouples shall be replaced or recalibrated on a quarterly basis. When base metal load sensors are used, they shall be controlled as follows. If they're expendable load thermocouples, they are limited to a single use. If they're non-expendable, they shall meet the requirements of AMS 2750F Table 6 and shall be recalibrated or replaced anytime observations are made, recorded on a weekly basis, reveal any unexplainable difference between their readings and the readings of the two recording sensors. Furthermore, the weekly readings that are required shall be done at one production set point measured within 5 minutes of the end of a production soak period and shall be compared. That relationship between the control sensor and the additional sensor in each control zone shall remain within 2 degrees Fahrenheit or 1 degree Celsius of the relationship determined at the time of the most recent TUS and at the nearest temperature during the most recent TUS. The additional sensor may be the overtemp sensor. Those weekly readings shall be taken from the same sensor pair between 2 consecutive TUSs. Lastly, along the waivers, the 2 sensors chosen shall be different types following the same restrictions as the resident SAT sensors in AMS 2750 Table 16, and shall be restricted to types B, R, S, or N at temperatures greater than 500 and shall be non-expendable at temperatures greater than 1000 degrees Fahrenheit. During each periodic TUS, that relationship between these 2 systems shall be determined by calculating the temperature of the control sensor minus the temperature of an additional sensor at time within the final minutes of the TUS soak period to determine the relationship at each TUS temperature. This is where you get your relationship that stays within the 2 degrees between the 2 existing sensors. As you can see from the table that supply here, again, your sensors, if they're noble metal and you're being control and recording sensors, those will have to be replaced every 2 years. And if you're using base metal thermocouples at control and recording, those would have to be replaced on a quarterly basis. Also, the different sensor types that has to be used for your comparison check. So if you're using your control sensor and it's type S, you would be able to use a type N or type B sensor. You wouldn't be able to use a type R since the dissimilar metals that are in those consistencies of those thermocouples. So this table here shows you what your additional sensor must be to do your weekly comparison checks against. We also added some documentation requirements when you are conducting the SAT waiver. Again, the previous revision didn't give you any guidance of how to document this, but now there's new requirements for the documentation. Again, identification of the thermal processing equipment that you're conducting the waiver on, identification of the control sensor, and that additional sensor system used for the sensor relationship test, the date of the installation of your control and additional sensor that's being used for a relationship test. You also have to denote the run number and date of the production thermal cycle when you do your weekly comparison check, date and temperatures of the most recent TUS, documentation of the sensor relationship test at each TUS temperature, and a documentation of weekly readings and the results of the sensor relationship test. Again, some new requirements that have not been introduced until Rev F. Now we're on to temperature uniformity surveys and some of the changes that were addressed in Rev F. We did address modifications and repairs. We've changed up a little bit of the requirements, what defines a modification and repair, and what's supposed to happen after one of those events occurs. We addressed vacuum levels during a TUS. We also defined the location of TUS sensors for volumes of less than 3 cubic feet. We changed some documentation requirements, and also the criteria for radiation test surveys also has been revised. So those who are familiar with Rev E, when it came to maintenance, modifications and repairs, there was two sections. There was major modifications and repairs. And they listed various items, what were considered a major modification and what were considered repairs. The repair section has actually been removed, and we list out the major modifications. So when any kind of maintenance is performed on any thermal processing equipment, it shall be documented, and the user's quality organization shall determine whether any testing is required. So in other words, quality will need to get involved after any kind of maintenance or repair is done to the furnace, and handle if a temperature uniformity survey needs to be performed. So some of the changes we made also to major modifications or repairs. So we addressed if you relocate a furnace or an oven. An initial TUS may be waived if the furnace or oven is designed to be portable. There was a lot of misconceptions. If a oven or furnace is moved from one location to another, it automatically required an initial survey. But they do, there's many manufacturers of furnaces and ovens now that put them on wheels so they can be portable. But it will be up to the quality assurance organization to determine if an initial survey or some sort of periodic test may need to happen prior to putting it back into production. We also require an initial survey if the control sensor is changed. That means if the type or the thickness of the sensor, or the sensor assembly, the gauge of the sensor, or the hot junction construction has changed, that could actually have a major effect to thermal processing equipment. If you also change the location, which was also in the previous revision, required an initial survey. But now we're saying if the construction of the thermocouple that you may be changing, again, if it's different size, diameter, or the hot junction is exposed versus unexposed, then an initial survey will be required. If there's also a change in the PLC logic program for a furnace that changes the heat control scheme, an initial survey will be required as well. So we addressed vacuum furnaces that are operated both in vacuum with no gas or under a partial pressure, with such as the backfill gases, argon, nitrogen, helium, during production. A periodic test shall be performed at least annually at one single operating temperature and within the partial pressure range during use for production. This is not an additional test. For instance, you have a vacuum furnace that needs 4 quarterly surveys during a year. And let's say you have a partial pressure in nitrogen run at anywhere between, let's say, 200 microns and 1,000 microns. All we're requiring is that you have to run one of those tests under a partial pressure in any part of the partial pressure range that is defined by the user. It's not a separate test, it's just a part of your quarterly testing process. We allow for any gas that may be used in production to be used for this partial pressure test. We address the location of TUS sensors for volumes that are less than 3 cubic feet. In AMS 2750E, it was ambiguous of where those thermocouples needed to be located. For instance, in a square furnace or rectangular furnace in Rev E, we just said 4 thermocouples needed to be in the corners and 1 in the center. So we've updated what the expectation are for work zone volumes that are less than 3 cubic feet. So in this instance, if you're choosing your 4 corners here and you want to choose location 1 and 4, that's acceptable. Then you would have to use locations 7 and 8 in the back of the furnace. which is opposite corners from the front zone, and then again 1 in the center. For a cylindrical furnace that is less than 3 cubic feet, you'd have your top thermocouples 180 degrees apart from each other, and the bottom thermocouples 180 degrees apart from each other, but those would be 90 degrees perpendicular to the top of the furnace, again 1 in the center. This gives us a better look at what the furnace is doing from front to back and top to bottom in these locations. When it came to TUS documentation, a few new changes are required in the documentation packages for TUSs. First off, they're going to require the control instrument tuning parameters. Also, you're going to have to require the TUS, the control and recording sensor location identification by applicable instrumentation type. For instance, if you have instrumentation type C, you're going to have to show where those recording sensors are located in a 3-dimensional space on your diagram. You have to list out the atmosphere that's being used during a uniformity survey. If you're using endo, air, partial pressure, or full vacuum, those will be now required as part of the TUS documentation. The TUS instrument correction factors shall be stated even when the correction factors have been electronically applied to the TUS instrument. So those correction factors will now have to be documented somewhere within that documentation report. A few more other requirements for TUS documentation. So you're going to have the results of the hottest and coldest TUS and furnace recording sensor relocation analysis for types A and C instrumentation. So when you reviewing your TUS and you have types A and C instrumentation, you're going to have to evaluate that data to make sure those types high and low thermocouples, the hot and cold thermocouples, do not need relocation. If you are performing a survey on a semi-continuous or continuous furnace, the traverse speed or the shaker frequency for the TUS will now need to be documented. And lastly, if the temperature uniformity surveys are being performed by a third party, that authorized agent quality organization shall approve the documentation as well. So the change for the radiation test survey, prior release of the specifications in AMS 2750E and before, it only required that the radiation test surveys be performed on all solution heat treating of aluminum alloys. And the wording has changed. Now it's required for all aluminum alloy thermal processing used above 800 degrees, where the heat source is located in the furnace walls, ceiling, or floor. In other words, those suppliers that would have a vacuum aluminum braze furnace, for instance, now will require a radiation test survey on those furnaces. And those radiation surveys shall be performed at the maximum operating temperature used during production. So everyone's favorite topic in AMS 2750 when it came out in Rev E was rounding. And we finally addressed rounding in Rev F a little bit more clear and better understanding. So first off, all rounding must be applied in accordance with a documented procedure and used in a consistent manner. So you are allowed 3 different methods of rounding: ASTM E29 using the absolute method, or an equivalent international standard such as ISO 80001 Rule B, or you're allowed to round per any commercial spreadsheet. So the way we learned in school, where it was 0.5 round up by a commercial spreadsheet, we are allowing that as long as this is documented in a procedure and always used in that consistent manner. All specified limits in AMS 2750 are absolute, and out of tolerance test or calibration data cannot be rounded into tolerance. For instance, if you do have a survey that you're shooting for plus or minus 10 and it reads plus 10.4, you are not allowed to round that into compliance. Now to the last table in AMS 2750F, and this has to do with calibration or test interval extensions. We are fixing a flaw that we had in Rev E. The previous revision did not address bi-monthly nor 4-month intervals, so we added this into now what is now table 25 in AMS 2750F. We also addressed if the extensions for any calibration or test are used, they shall be documented with a written justification and must be approved by a user's quality organization. So for instance, let's say calibration is due on a Sunday, It was done on the following Monday. That extension is going to have to be documented and approved by the quality organization. Lastly, when it comes to the quality assurance provisions, beginning 2 years after the release of AMS 2750F, any third-party pyrometry service providers shall have a quality system accredited to ISO IEC 17025 from ILAC, International Laboratory Accreditation Cooperation, recognized by regional cooperation bodies. Their scope of accreditation shall include laboratory standards and/or field service as applicable. A pyrometry service provider that is accredited to ISO IEC 17025 does not require procedural oversight for services performed on site. So 2 years after the release and you're having third-party calibrations done at your facilities, they will be required to be 17025 accredited for the field that they're doing calibrations or testing for you. I thank you for the opportunity this morning to go through the key changes of AMS 2750. I know the presentation didn't cover every single change in the specification, but wanted to give you a clear idea of some of the major changes within the specification. I look forward to talking with you virtually of any questions or concerns you have with the specification. I know I'll be around for a couple hours to answer some of those questions or concerns. If time doesn't permit, you can always reach me at my email address attached to this slide, as well as my phone number, and I look forward to answering anything I can for you. Thank you and have a great day.